Hello, my name is Daniel Lim, and this is my Physics 2211 Lab 4 presentation. So for the introduction, the purpose of this lab was to analyze the oscillatory motion of a mass attached to a spring in 2 dimensions by tracking the position of the mass over time and applying Newton's laws of motion. We can also model the motion through restoring forces of simple harmonic motion and compare them with observed data that we get from Tracker, and also using GlowScript to simulate the motion of the mass. And we examine how the spring's stiffness, the mass, and overall gravitational effects contribute to the motion. So some of the fundamental physical principles used in this lab include Newton's second law, Hooke's law, the kinetic and potential energy relations, and the conservation of energy. My brief hypothesis was that the simulated spring mass motion would be very similar to the experimental data that we see from Tracker, from GlowScript. So for the experiment, for the Tracker data, we had mass displaced from equilibrium and a spring attached to the mass at a fixed point. And then using the video that we can put that through Tracker and get the X and Y positions of the mass at certain time steps. And then we save that in a .csv format. For the computational model, we had a fixed end of a spring at origin, and then the mass would start from a displaced position recorded in Tracker. And then some of the initial conditions were that the initial velocity was set to 0. Kind of a summary, we analyzed the 2D oscillatory motion of the spring mass system. In part 1, we did the Tracker with the actual video of the simulated motion, and then for part 2, we simulated it through GlowScript with code. So here's what the Tracker looked like. So this is the video along with the benchmark meter stick right here, and also some of the axes, and here's what the data look like from Tracker. Here's the GlowScript code. So on the left block of code, you can see the ball's mass along with the initial position and velocity vectors that we got from the Tracker data. And then on the right is the while loop that calculated the initial energies along with gravitational and spring forces. And then using the momentum principle, we updated the spring's position and also the spring's magnitudes, and then we recalculated the energy changes. So here are the results of both the Tracker and GlowScript. So on the left is what the Tracker data look like, and then in the middle is the GlowScript code's X and Y positions. So the blue is the model, and then the red is the experiment. And then on the right is the changes in energies of the GlowScript code. So some similarities would be that they had similar oscillatory patterns and matching frequencies, and also energy was conserved in both parts. But one difference was that the amplitudes of the X and Y axes of the mass varied between the GlowScript and Tracker. This could be possibly due to that the Tracker data might have encountered some external forces like air resistance or prior momentum or even like humidity. So the results did align with my hypothesis that the motion would look very similar. So what does this mean? For the energy principle, yes, it was satisfied. The total energy curves stayed nearly constant while the kinetic, gravitational, and spring energies oscillated out of phase to sum to roughly 0. And then for oscillatory patterns, estimating the period from peak to peak spacing in the X data and again in the Y data gives nearly the same value. Any slight mismatch is consistent with tracking noise, calibration, perspective error, and minor coupling and damping that affect one axis a bit more than the other. Thank you so much.